All right, thank you very much. Good afternoon, everybody. You know, I can't help but think of Andy Warhol and his famous quote about 15 minutes of fame. That's all we get in life. And this could be it. So I so appreciate your sharing this 15 minutes with me as I tell you what is really kind of a rags to riches story for an electrical engineer. I started off in Fairfax City as a little kid who was really enamored with crystal radios. In fact, I built a crystal radio that I put inside an ink pen that used a little germanium diode, and I brought it to school and listened to AM radio, and that was really cool. I just couldn't believe radio actually worked, and I wanted to know more. So I started listening to shortwave radio when I was 9 years old, international broadcasting. It was so big back then, HCJB and Radio Netherlands. And I couldn't believe how this worked. And I wanted to know so much more. So I went around the corner with a buddy of mine who also wanted to become a ham, Phil, who's now W4YHD. And we knew there was a guy next door that had a vertical antenna in his backyard. We knew nothing of what it meant. We knocked on his door, half expecting to be told, "Get out of here." So we're about ready to run. And he says, "No, come on in." And it was my Elmer, Al Wheeler, WB4JJJ. And he showed us ham radio, helped us get our licenses. So at 13 years old, I'm a novice. And I thought, this is cool. I had no idea this was available. Now, my parents were military. My father was in the Air Force as a colonel. My mother was a nurse, and they didn't know anything about the engineering field, really. So there was nobody to guide me. So then I got my general class license at 14 years old, went down to 1919 M Street, local to Northern Virginia. I thought I was going to see God. And I did see him, and I passed my general class exam. So I thought, maybe I can do something, make something of my life. Well then, once I got my general class license, I then ultimately came back at 18 years of age and got a commercial broadcast first class radio telephone license with radar endorsement, because I was interested in broadcasting. And then eventually, of course, I became an extra class license when I got out of college. And my education along the way, as I tell you my little rags to riches tale, I'm a Fairfax High School graduate, 1975. I achieved my Bachelor of Science in Electrical Engineering at Virginia Tech in 1980, an awesome school. And then I ultimately got a master's degree in electrical engineering from the Johns Hopkins University in 1991, with specialization in RF and microwave engineering and radar systems in engineering. But that's not really the story here. So how did this all begin, and how did this all unfold? Well, here I am with my novice license, and I'm seeing this world of radio that I did not know existed. So here's amateur radio, building a vision for a career my parents couldn't guide me on. So I got involved with the local repeater club, the Northern Virginia FM Association. They had a good membership, and there was a lot of building and experimenting going on. Repeaters were new, and I wanted to know more. So I got involved with building the 146.79 repeater, where we use TTL logic and these little circuit cards that you see in the card cage there. And so I ended up designing and building TTL logic circuits to bring new features to the repeater. I also maintained the RF and learned a lot about those skills. And then suddenly, when I'm a junior in high school, everybody left. And it was just me to maintain the fidelity repeater with audio processing following what's known as an optimod with various compression techniques. I built a super high fidelity repeater there for 220 for the club, put antennas on the roof and so on. So here I'm building skills and I'm getting involved with mentors showing me the way. So then I go off to college at Virginia Tech, and I was really interested in broadcasting and broadcast engineering. Had never done that before, and I like high power RF transmitters. So I show up on campus, I tune in the college radio station, very good progressive music format, and they're looking for talent, for disc jockeys. So I called them on the phone, and I said, hey, I'd like to get involved. And they said, well, you need a license. And I said, well, I have one. And what you needed was a third-class radio telephone to be a disc jockey back in those days. No longer is that needed now. I said, I got a license. I have a first-class radio telephone. He said, whoa, we need you. Within 4 days, I had a live show on the college radio station. Again, the passion is building. And so here I am working on a transmitter on the left side here. This was a project during my time at Virginia Tech. We were running a transmitter that did 770 watts ERP, and it had this really unique final amplifier called a GNM 69. The designer is right over here, Jeff Mendenhall, W8GNM, and this thing worked so well, but we wanted to go bigger. So we got this old RCA transmitter, a BTF5, and we lovingly redesigned it, not redesigned it, we re-silver plated it and modified it and brought it on the air and took our power to 3,000 watts. What a project that was. And here I'm learning more about high power RF and power grid tubes. And all the folks in the engineering group at WUVT were all hams, so that was a big plus. Here I am doing a radio show. The bottom right photo there is we're putting up a brand new 2-bay broadcast antenna. Look at all this RF experience that I'm getting. So where is this leading me? Well, I go into the defense industry, working on high power communications equipment, radar equipment, and networking with a lot of hams. But what's really key at this point is the mentors that I was meeting through amateur radio were so valuable, saying, watch out for this, here's a good career opportunity, here's where you can be strategic and make some money. But the most important message that these mentors met through amateur radio, who were electrical engineers, the most important message was follow your passion. And if you can follow your passion, you'll never work a day in your life. And boy, were they right. So with that in mind, I had finished my master's EE at Johns Hopkins, and I was looking for some new opportunities, and I couldn't really find anything with the company I was working for. It had turned into Raytheon at the time, and they said, oh, just be quiet and go back to your desk. Well, I thought, what did I go through all that pain for to get a master's? So I then found HARP, and I went to the HARP office in Washington, D.C., and I said, I want to talk to your RF guy. And they hemmed and hawed, and they said, well, we don't really have one. And I said, what do you mean you don't have an RF guy? This is an RF site. So ultimately, I talked my way into a job becoming the chief design engineer and the chief RF engineer for HARP up in Alaska. Now, when I joined the program, I then found out that the program had collapsed. They had contracted out all the RF, all the control systems to contractors who were not passionate or didn't have ownership of the project. They did not do well. So many innovations here. I can't even begin to start. But just a few examples here. Here's a 180 tower HF transmitting array. There are 180 transmitters that we designed in our project office. And this builds a total input power of 3.6 megawatts for an ERP of 5 gigawatts. Doesn't it just figure that a ham would be crazy enough to try this and to have the passion to go for it? Well, that's what happened. 2 examples. On the top right here, that's an antenna matching unit. This is a 20 kilowatt antenna matching unit, completely designed in our office. It's not allowed to have ferrite. It had to have insertion losses of 0.2 dB or less. And so that's a 4-port hybrid transformer that has the Balun function, impedance matching, and what's called an even mode dump port because of mutual coupled power that we were dealing with. On the bottom right corner, you'll see another innovation we came up with, which was we put current monitors on every single dipole. And we brought those samples back and did an A to D conversion, and using a NEC 4 model, we calculated our antenna pattern and calculated our ERP and our side lobe levels, all from real-time measured RF current on every dipole in the HARP array. That's never been done before. And again, the passion behind my amateur radio experience and knowing that I could try things outside the box and it could work. Here's another example, pictures of the HARP site. This is a transmitter shelter building on the left, 6 transmitters, 20 kilowatts each, largely designed in my office with my team. And these transmitters are designed to do AM, FM, phase mod, pulsing with user-defined rise and fall times, and he can do them all at the same time. Who in the world would think of doing that? An amateur radio operator. We try things new. We also innovated a technique of using a network analyzer to do a precision calibration on these transmitters. Continental Electronics, our contract manufacturer, had never seen that done before. Again, amateur radio, experimenting, using what you have, innovating. The bottom right corner is the operations center up at the site. We do remotely operate the site over the internet quite often. So you can see how this kind of built for me. Here's the little kid in Fairfax City who loved radio more than anything in the world. My father, bless his heart, wanted me to go to college, but he always said, become a draftsman. You'll always have work. So he always felt that I should be a draftsman. I decided I wanted to be an engineer, but with the mentoring and with the passion and with the thrill of success that I had experienced in amateur radio, this career came true. A couple of more quick comments as I wrap up. There's another advantage to amateur radio beyond getting people into these professional careers with confidence, beyond the innovation that allows you to experiment outside of a textbook. And that is, I can't tell you how many times I've been in meetings when things are not going well. The customer wants one thing, you can only do this, it's contentious, and you realize there's a ham on the other side of the table. HARP is a beautiful example. Here I am trying to build this site, and the program manager out of Naval Research Lab, Ed Kennedy, K3 North South, he's a very active ham. We immediately were friends, we immediately communicated well, and I can't tell you how many times we took conflicts privately between the two of us and figured it out and finished the job. Amateur radio is a great network. So innovation examples achieved at the HARP facility here. I talked about 180 towers, with a 5 gigawatt ERP, only a ham would attempt it, and we did it. The measurement of radiated antenna patterns with real-time current, antenna matching unit, no ferrite, we're not allowed to do that with many features, and these incredibly multi-mode transmitters with very low noise. Quick comment here, I also did work on some S-band radar designs here called AMDR, where I was able to innovate these radar modular assemblies with an internet protocol back end. Again, very new innovation, not worrying about trying things new. So what's the advice and the takeaways here? Well, amateur radio clearly provided me with the knowledge and the inspiration to build a career in electrical engineering that I simply never knew existed, and I may not have ever known this. Secondly, I would recommend for any young hams, join an amateur radio club, even if you're older. Join an amateur radio club or special interest groups. Get out of the shack and build your network of friends and mentors to guide you. That was absolutely key for me. Stay active in the hobby to continue to be exposed to new technologies and continue to build your skills. That's how you stay young. And if you follow your passion, you will never work a day in your life. That is the best work outcome possible, and that's what happened to me. Thank you.
Thank you, Steve. I think you should feel free to ask Steve a little more about HARP. He's the man, and it's a fascinating facility. If you're interested in HF antennas at all, you're going to see the primo, highest quality, highest precision devices ever used in HARP. And I'm sure Steve would be happy to fill you in.